mass is used when you're trying to plane.
Okay.
I even wrote a paper about it, talking about how you can apply flaking to center of mass, and it can be applied to many different aspects of life.
Wow!
Hi! So, to understand center of mass, the first thing you need to know is that for an object to be balanced, all of the force acting on the object must be equal to 0. For this to happen, the forces around an object must be opposite but equal. The first demonstration that we can see this in is with the stability model. With this model, you can see where the center of mass is and at what point it will align with at the base of this object. So, when you put this object down on the ground or on a flat surface, you can see that the point of the center of mass is actually aligned to a point that's directly on the base of this object. Because of that, when I let go, it'll stay balanced. But if you flip it upside down, the center of mass is actually at a point that's off of the base. So when I put this one on a flat surface, it will fall. And same goes for when it's on an inclined plane. When it's on an inclined plane, the stability model will show that the center of mass is still aligned on the base. So if I put this, even though when it was on a flat surface it will fall, if I put it on an inclined surface, it will stay stable. Now that you understand what center of mass is, you can learn about balancing things. And try and balance, all of these nails on this one nail.
Okay. Look, got one.
Good job. Keep on going.
Okay.
Slowly.
I got one. No, I don't have any. Okay.
Okay. So the problem that you were having is that you were adding on one at a time. Because of this, you're adding more and more mass and changing the system every time that you added more mass. So the center of mass changed every time that you added a nail. So in order to fix this problem, you need to make these nails into a system and then find its center of mass and balance it on this one nail.
Okay.
So when you do this, you're going to want to start out with a nail on the bottom, and then you're going to alternate nails in order to keep the mass distribution the same on both sides.
What the?
You're going to want to keep on doing this until you get to your last nail. Because nails are inherently not centered, the center of mass of this nail is actually more towards the head than it is towards the end of the nail. Because of this, when you have the center of mass, when you have the nail on the bottom, you're going to want to flip this nail on the top so that the center of mass is equal on both sides. So, made your system. Now, this system was made specifically so that the center of mass would be somewhere in the middle. So once you find that point, you can balance it on that one nail.
Wow. Physics.
Moving on to the next demonstration. Since you know about center of mass and how to find your center of mass, now you can learn how to manipulate your center of mass.
Manipulate?
Yes, and all you need are some Jenga pieces. You're going to want to start out with Jenga pieces aligned like so. First 3 like this. Then you're going to keep on adding more and more. Now if you remember when you were trying to balance all of the nails on that one nail, you kept on, whenever you added more nails, you added more mass to the system, which inherently changed the center of mass. So before I start adding, the center of mass is somewhere in between these two pieces. So when I add more and more mass to the system, I'm going to end up changing where the center of mass is. And can you tell me which side of the center of mass I am adding more mass to?
You're adding it.
Exactly. So do you know where the center of mass is probably going to be shifted?
Onto this one.
This one. Exactly. So you're going to keep on adding more and more until you reach about 7, 6, 7, or more.
Oh my gosh.
Okay. So now that the center of mass is aligned over here, do you know what we need this piece for?
Nothing.
Exactly.
Oh my gosh.
Nothing.
That's awesome.
The center of mass was moved from the middle to align somewhere along this piece. Therefore, the system is balanced because center of mass is aligned on this piece. Yes, you can poke it. Now that we talked about transitional forces, let's talk about rotational. Here, I challenge you to spin this faster than I do.
Okay, I mean, I've been working out lately, so.
Ready? Go. Let's try that again.
Okay.
Ready? Go.
Go, go. Okay, wait, no, I want the blue one now.
Okay. Ready?
Okay, I feel like you're cheating, like,
I'm
your
not
muscles.
cheating. No. Okay, so the reason that this is, I'm actually spinning it faster than you is because I'm spinning it to the left while you are spinning it to the right.
So weird.
Exactly. In this spinner, the center of mass is moved slightly to the left. Therefore, whenever I was spinning it towards the left, the center of mass was working with the rotational motion and making it spin faster and longer than when Anne was spinning it to the right because it was moving against her rotational movement. Another cool thing about these is that when you put them on a near frictionless surface and you press down on it, it's going to start spinning towards the left. This is because the center of mass is always going to be pulling down on the object towards the left, towards a little bit towards the left because it's slightly moved to the left. And it's always going to want to move in that direction because it wants to reach equilibrium. On to our...
I want a rematch.
Okay.
Let's go. Ready?
Ready?
Oh darn, you still won.
In this last demonstration, you're going to be needing to use a sturdy bar that won't move, a ruler, a piece of string that's tied into a loop, and a hammer. Be careful because the hammer is really heavy and if it falls, you could hurt yourself. So you're first going to put the loop through this side of the hammer. I like to put it in the middle because it means that it won't slip off so easily. After you do that, you're going to put the ruler through the same loop like so. Then you're going to put that end of the ruler on the bar. And your system is balanced. In this system, we have two rotational forces. The forces are called torque, and the first one is the ruler turning clockwise around this bar, and the second one is the rotational movement of this hammer that is going counterclockwise around its center. Because you have a counterclockwise force going up and the clockwise force going down, at this point they balance each other out and are balanced. So now that you know about center of mass, do you want to try planking again?
Okay, I got it this time. It's gonna be somewhere around here, right?
Yes, your middle.
Okay, ready? Oh yeah, look at me, Mom.
Thank you for watching my PBL video. I hope you learned about center of mass.